Hi, I'm April and welcome to the channel. I teach math to high schoolers. In this video, we're gonna go over a standard level analysis and approaches test, paper 1. In the next video, we'll go over paper 2. The way that we do assessments at our school is that the tests are cumulative in nature, meaning that at this point of the year, we've covered 3 different units so far, which includes series and sequences, binomial theorem and proofs, and linear and quadratic functions. So this test paper will cover all of those topics. This video is designed so that you can take the test with me. The general rule of thumb is that each mark roughly corresponds to 1 minute. So if you see a question that's worth 4 marks, then you should allocate about 4 minutes on that question. Of course, if you finish sooner, you can skip ahead and do the next question. So I've added timers in this video so that you can take this test and try the questions along with me. It is really important to make sure that you are attempting the question. You're not only looking at the solutions, because that is the only way that you can become a better mathematician is with practice. Here's question 1. Let f of x equal minus 2x plus 3. A. The graph of a linear function g is parallel to the graph of f and passes through the origin. Write down the equation for g of x. B. The graph of a linear function h is perpendicular to the graph of f and passes through the point minus 1, 2. Find the equation for h of x. Please take 3 minutes and try this question. All right, let's answer this question together. So we know that the graph of g is parallel to the graph of f, which means that they must have the same slope. We also know that it the point passes through the origin, telling us that the y-intercept is at 0, 0. So the slope for graph f, so the slope of f is minus 2. And since equation G is parallel to f, then it has the equation minus 2x. Part B. So now a new function h is perpendicular to the graph of f, meaning the slope of h has to be the negative reciprocal of f. That's going to give us 1 over 2. We know it passes through the point minus 1, 2. So we can use the point slope form of a line to write our equation. Sorry, this should say y. So instead of y, we're going to use h of x. Our equation becomes h of x minus 2 equals 1/2 x plus 1. And we can rearrange this equation to solve for h. All right, that's question 1.
Question 2, solve for x. Please pause the video now and take 4 minutes to try and solve this question on your own.
All right, let's see how you did. So notice for the first equation that x is already isolated, so we do not need to expand this equation. Instead, let's continue isolating for x. We can start by dividing both sides by 2, giving us x plus 1 squared equals 16. Taking the square root of both sides, and remembering that we need to take the plus or minus root, we are left with x equals minus 1 plus or minus 4. So square root of 16 is 4, but I need the plus or minus root. I move the 1 to the other side, giving us minus 1. So one solution is going to be minus 1 plus 4. That's going to give us 3. And another solution is going to be minus 1 minus 4, giving us minus 5. We can easily check our work by plugging in 3 into the original equation and plugging minus 5 back into the original equation to see if it makes the equation true. Let's take a look at question B. So question B is an inequality. Whenever we're dealing with inequalities, whenever we're dealing with quadratic inequalities, it's best practice to first factor your expression. So x squared minus 4x minus 5 factors into x minus 5 times x plus 1. Now, in order to figure out when this quadratic would be less than or equal to 0, I can sketch a graph of what this would look like. So let's do that on the side here. I know that this quadratic has x-intercepts at minus 1 and positive 5. And I know that it opens up since the a value is positive. So from here, I can see that this quadratic function is going to be less than or equal to 0 in between the x values of minus 1 and 5. So my final answer is going to be minus 1 is less than or equal to x, which is less than or equal to 5. All right, please take 5 minutes and try this question on your own. So this is a question about the nature of the roots. What we know is that if this quadratic equation has two distinct real roots, then the expression for the discriminant has to be greater than 0. So you'll notice that we already have a quadratic equation in standard form. In order to use the discriminant, we need to identify the values of a, b, and c. The a value is going to be the value that's in front of the x squared. So this is the coefficient for our x squared term. The b value is the coefficient for our x term. And the c value is going to be our constant. So here's our a, b, and c. Because this equation has two distinct real roots, we know that the discriminant, b squared minus 4ac, has to be greater than 0. So let's replace b, a, and c with our values from the equation. We're going to get 2 squared minus 4 times k minus 1 times 2k minus 3. And that's greater than 0. Let's simplify. 2 squared is 4. I'm going to multiply these two binomial expressions together. I'll leave the 4 outside for now. K times 2k is 2k squared. K times minus 3 is minus 3k. Minus 1 times 2k is minus 2k. And minus 1 times minus 3 is plus 3. And that's all greater than 0. Now let's simplify and combine these like terms together. So in the brackets, I'm going to have 2k squared minus 5k plus 3. And that's all greater than 0. Let's continue to expand this expression and use the distributive property. So I'm going to have minus 8k squared plus 20k minus 12 is greater than 0. Again, we can combine these like terms together, giving us minus 8k squared plus 20k minus. Now notice that each of these terms is divisible by minus 4. So we can simplify our expression by dividing both sides by minus 4. When I do that, I need to flip the inequality symbol. So instead of being greater than 0, this expression now will be less than 0. Minus 8 divided by minus 4 gives us positive 2. So we have positive 2k squared. 20 divided by minus 4 is minus 5k, and then minus 8 divided by minus 4 is plus 2. From here we can factor our expression on the left-hand side. So 2 is a prime number, so I know that my factors must contain 2k and k. Then I'm going to look at this constant value of 2 and see what are the factors of 2 and how I can arrange those factors so that when I expand the expression, I get minus 5k. So I can see that if I put a negative 2 here, when I multiply 2k by negative 2, I'm going to get minus 4k. And then minus 2 times minus 1 gives us positive 2. And so that minus 4k would combine with the minus 1k to give us minus 5k. So these are my factors. Now that I have these factors, I can do a quick sketch on the side and see what this quadratic function would look like. So I know I'm going to have a x-intercept at 2 and also at 1/2. And this is going to open up. And now I look for when this expression is less than 0. So that's going to be between the values of 1/2 and 2. So k has to be in between 1/2 and 2. Question 4. Prove that the sum of any 4 odd numbers will always be even. Please pause the video and take 4 minutes to try this question. All right, so the first step to any proof question is that we need to define our variables. So we need to create some odd numbers. So let's begin with a let statement. An odd number always has the form 2 times some integer plus 1. And we need 4 different odd numbers. And we don't know if they're consecutive, so let's use 4 different variables. Let's say 2m plus 1, 2n plus 1, 2p plus 1, and 2r plus 1. So we'll let these expressions be 4 odd numbers, where m, n, p, and r are all in the set of integers. Now I want to take the sum of these numbers, so I'm going to add them together. 2m plus 1 plus 2n plus 1 plus 2p plus 1 plus 2r plus 1. Let's combine our like terms. So I'm going to get 2m plus 2n plus 2p plus 2r plus 4. And since I want to prove that the result is even, it means I need to take out a factor of 2. And I can do that. When I remove a factor of 2, I am left with m plus n plus p plus r plus 2. I can rewrite this as 2k, where k is also an element of integers. Include some sort of explanation, and finally, don't forget to have a concluding statement. So therefore, the sum of any 4 odd numbers is always even. Question 5. The following diagram shows part of the graph of a quadratic function f. The graph of f has a vertex at 3, 4 and passes through the point Q as shown. A. Point Q has coordinates 5, 12. Write the equation of the function in the form f of x equals ax minus h squared plus k. B. A function g of x equals 4x minus 2 intersects f at 2 points. Find the coordinates of the points of intersection. Please take 7 minutes and try this question on your own. All right, so let's talk about this question. We already know the values of h and k, since those are the coordinates of the vertex. So we can plug in our known values in our equation, and the only unknown that's left is a. To solve for a, we can use another given point on the graph, which is point Q. We know the x-coordinate is 5 and the y-coordinate is 12. So let's replace the output value with 12 and the input value with 5, and then we're going to solve for a. When we do that, we get a equals 2. Don't forget to plug that back into the equation, and here is our final equation for f of x. Question B is asking us to find the coordinates of the points of intersection of g of x and f of x. So here's the equation for g of x, and then here's the function f of x. So what we want to do is to set those two equations equal to each other. So 2 times x minus 3 squared plus 4 is equal to 4x minus 2. Let's open these brackets up, giving us x squared minus 6x plus 9 plus 4 on the outside. And let's move 4x minus 2 to the left-hand side to set this equation equal to 0. Now we have to continue to simplify. So this becomes 2x squared minus 12x plus 18 plus 4 minus 4x plus 2 equals 0. Let's combine our like terms. So we have 2x squared, we have a minus 12x and a minus 4x, that gives us minus 16x. Then we have 18 plus 2 is 20, plus 4 is 24. Great. Notice that each of these terms is divisible by 2, so I can simplify this by dividing both sides of the equation by 2, giving us x squared minus 8x plus 12 equals 0. And to factor this expression on the left, I look for two numbers that multiply to make 12 and add to make minus 8. Those numbers are going to be minus 6 and minus 2. So our factors are x minus 6 times x minus 2. That gives us values of x of 2 and 6. Now, those are just our x coordinates. Remember, we're asked to find the coordinates of the points of intersection, so we need their corresponding y values as well. We can plug those x values back into g of x to find their corresponding y values. So let's go ahead and do that. Let's look for g of 2. So that's 4 times 2 minus 2, which is 6. And then let's look for g of 6, which is 4 times 6 minus 2. That gives us 22. So therefore, our coordinates are 2, 6, and 6, 22. Question 6. Find the sum of the series given by this expression showing the use of an appropriate formula. Please take 4 minutes and try this question on your own.
So the first thing we need to do is recognize that this expression, 3n minus 2, gives us an arithmetic sequence. When we take the sum of all the terms in that sequence, we have a series. So here we need to use the sum of it. We need to use the arithmetic series formula. There are two of them, so you can use either one. The first one that is provided in your formula booklet is S sub n is equal to n over 2 times u sub 1 plus u sub n. And the second one is S sub n is equal to n over 2 times 2 times u sub 1 plus n minus 1 times the common difference. If you're using this formula, you first need to figure out what u sub 1 is. So if we replace n with 1, we're going to get 1. That's the first term in our sequence. Then to find the last term, well, the last term is given by this upper limit. So we need to figure out what u sub 20 is. If we replace n with 20, we're going to get 60 minus 2, which is 58. So to use this formula, we're looking for the sum of the first 20 terms. That's 20 over 2 times 1 plus 58. This becomes 10 times 59, which is 590. All right, if you're using the second formula, again, we need u sub 1, which we've identified as 1 by replacing n with 1. We also need the common difference. That's given by the coefficient in front of n. So if you think about this as a linear function, it's a linear function that has a slope of 3, meaning it goes up by 3 every x unit. So our common difference is 3. So to find the sum of the first 20 terms, we take 20, divide by 2, then 2 times the first term plus, n in this case is 20, so 20 minus 1 is 19. 19 times our common difference, which is 3. 20 over 2 is 10. Then here we have 2 plus 19 times 3, which is 57. And then again, we have 10 times 59, which gives us 590. All right, the final question in paper 1, question 7. The cost of a mobile phone contract depends on the number of minutes spent talking each month. Contract A has a fixed cost of $8, then charged at a rate of $1 per 20 minutes. Contract B has a fixed cost of $10 for the first 100 minutes, then charged at a rate of $2 per 10 minutes. Julie wants to investigate the cost, C, of spending X minutes talking each month on both contracts. Write an equation that models contract A. B, create equations that model contract B and specify a valid domain for each. C, find values of X which both contracts cost the same. So please take 6 minutes to attempt this question. Part A, we are looking for an equation that models contract A. We know that the cost is given by C. So C is going to be equal to, well, let's see, there's a fixed cost of $8, and then there's a rate of $1 per 20 minutes. So the equation is going to be 8 plus 1 over 20x. For every 20 minutes, you get charged $1. Part B. Now we want equations, plural, here, that model contract B and specify a valid domain for each. So for contract B, there's a fixed cost for the first 100 minutes. So it doesn't matter how many minutes you're spending, up to 100, the cost is going to be $10. So C is equal to 10 for the domain from 0 until 100 minutes. That's the first equation. Now, the next part is that we have a rate of $2 per 10 minutes. Okay, so we know that the slope of this next line has to be 2 over 10, or 1/5. Now, we also know that a point on this graph, so if I were to, let's try to visualize this actually. So let's try to visualize this, contract B. Okay, so contract B, from 0 to 100 minutes, it's going to cost $10. At this point forward, your phone contract will cost $2 for every 10 minutes. So it's going to have some positive slope that goes up like this. So we know that this point, 100, 10, is going to be on this line that has a slope of 1/5. To find the equation of this line, we can use point slope form, plugging in our known values. So that's y minus 10 equals 1 over 5 times x minus 100. Let's simplify this. We get y equals 1/5 x minus 20 plus 10. And that simplifies to 1/5 x minus 10. Now we need to rewrite this using the correct variable. So our second equation is going to be c equals 1/5 x minus 10. And that's going to be for values of x that are greater than 100. So after the first 100 minutes, we use this equation to model the cost of the phone contract. Part C. We need to find values for which both contracts cost the same. So we need to figure out the values of x which make this true, 8 plus 1 over 20x equal to 10, and make this equation true, 8 plus 1 over 20x equals 1/5 x minus 10. Okay, since we have two equations for contract B. So let's take a look at the first one. Subtract 8 from both sides, and then multiply both sides by 20. So when x is 40 at 40 minutes, both contracts cost the same. Okay, let's look at the second equation. 1 over 20x minus 1/5 x equals minus 18. So I've combined the x terms together and I've combined the constants together. Let's find a common denominator here. So 1 over 20x minus 4 over 20x equals minus 18. That gives us minus 3 over 20x equals minus 18. Multiply both sides by 20 over minus 3. So we're going to get minus 18 times 20 over negative 3. 18, negative 3 goes into 18 6 times. So then x is equal to 120. So these are the values in which both contracts cost the same.
Thank you so much for watching. I hope you found value in this video. Please give this video a thumbs up if it was helpful to you and consider subscribing to the channel for more.